Hello everybody, my name is Austin Randall, and this is Matheson Price, Thomas Snyder, Dallin Weiberg, and Colin Karchner. We are the Hill Air Force Base non-flush patch repair team, working with Robert Cohn. We are the non-flush patch repair team working with Hill Air Force Base, and our project is comparing the effects of an airfoil with a patch compared to the airfoil without a patch. So you can compare how the performance changes when adding this non-flush surface to the lifting control surface.
All right, so as Austin mentioned, Hill Air Force Base uses a 6 degree of freedom simulator to study the effects of these non-flush patch repairs on their airplanes. And so our job, we're tasked with building an aerodynamic database based off CFD simulations for a wide spectrum of different airplane and airfoil configurations to fill this database. And then ultimately, one deliverable we'll be giving is a program of computer script that can retrieve the data and interpolate as necessary to fill the 6 DOF simulator's needs as far as the aerodynamic properties go.
So I'm going to continue with what Don was talking about for filling that database for the 6 degree of freedom model for Hill Air Force Base. So the first thing that we did is we created a geometry of an airfoil. I apologize for my art over here, but this is the airfoil that we would have created. We would have placed a patch at some location, and then we would have created a topos mesh around that, so it's got focus on the front and the back, and then one around the full thing there. And then from there, we imported these meshes into Genesis CFD, and it would create a data set for that mesh at different degrees of angle of attack. And then that would output those coefficients of drag and lift, and that's what we access with our Python script. When they type in the given parameters for a certain type of airfoil, it will then output the lift and drag coefficients for them. Additionally, we did create some 3D prints of an airfoil that we could run in a wind tunnel test. So this first one does not have any patch on it. Additionally, we did create another airfoil, and this one has a patch located right there. I don't know if you can see that, but it's a small patch at 25 degrees, or 25% of the chord. And then we place these, and these long discs are just to reduce the tip effects of the airfoil. And we placed that, we mounted it in the wind tunnel, and we could change the angle of attack with this sliding device there. And so we ran a series of tests on those airfoils to compare the effects of that patch, so that we could compare that with the data that we were getting from Genesis CFD, and see if the data that we're getting from there is accurate to what a real-life simulation would give.
Alrighty, if you guys look here, you can see we have some results from some of our CFD runs, and these have been plotted using ParaView. And here you can see we have, this is the velocity magnitude. So red is high, and then blue is low velocity. And you can't really even see the patch on there. But we can kind of see some of the effects that the airfoil is having on the flow around it. And we'll kind of flip through a series of different images here. So here's another same airfoil with the same patch, but at a different angle of attack. And you can see that the flow field is slightly different. And then you have the same velocity magnitude scale on the side. And then if you want to, we'll filter through a couple series of shots here. These are a series of Mach numbers. And you can really see kind of how that the airfoil there, or the patch on the airfoil, creates some separation from the airfoil and creates a gradient in the Mach number away from the airfoil. And then we'll also show a series of images of the turbulent kinetic energy. And these ones are really interesting, kind of fun to look at. You can see there's that flow really blowing up. And then in one of those images back there, we have those von Karman vortices that are forming off of the back of the airfoil. And that's an interesting phenomenon, and that has huge effects on the transfer of energy. And we'll talk all about that in our presentation.
Fun finally, we would just like to thank Hill Air Force Base and specifically Robert Hone, he's been our contact there, for giving us this opportunity to work on this project. We've learned quite a bit, and it's been a lot of fun. If anyone needs to get in contact with us, these are our emails.